We are from CS 143 to C and we are presenting MAT 183. My name is Nur Siti Sarah binti Muhammad Suhaimi. My matric number is 2019-264-244.
Hi, my name is Izyan Nabila binti Ismail, 2019-430-664.
Hello, my name is Putri Rojana binti Zaidi and my student number is.
The differential is the subfield of calculus and there are various applications of differential in real world. The differential is very important part of math as it is used in many scientific fields.
Procedure to find an equation that relates to different quantities, then applying chain rule to differentiate both sides respect to time. Okay, so there are 5 easy steps. Just for the first one is define the shape. Second, identify the rate of change. Third, determine the formula and equations. Fourth, differentiate the equation. And last one is substitute specific numerical values.
This is the question. Let's read the question together. A spherical balloon is being inflated at the rate of 9 cm³ over minute. Find the rate of change of the surface area when the radius is 50 cm. So, the first step, we need to know what the shape of this question. The shape of this question is a spherical balloon. Spherical balloon is the shape of sphere. After we know the shape of sphere, we need to know what's the question wants. The question given that inflated at the rate of 9 cm³ over minute. So this is the differentiate of dv over dt equal to 9 cm³ over minute. And the question 1, we to find the rate of change of the surface area when the radius is 15 cm. The question 1, we need to find differentiate of dA over dt equal to what and when radius equal to 15 cm. Okay, first step, we need to know what is the volume of sphere. This is the volume of sphere 4/3 pi r cube. Next, we need to differentiate volume of sphere become dv over dr equal to 4 pi r square. And then we need to put this formula into the conclusion that we get. Put in this formula and then we will get dr over dt equal to 9/4 pi r square. After we get the answer of dr over dt, is not finished yet because the question 1 we to find dA over dt when the radius is 15 cm. So next we need to know what is the surface area. Surface area is 4 pi r square. And we need to differentiate this become dA over dr equal to 8 pi r. And then we need to put the answer in this formula, and it's become dA over dt equal to 18 over r. It doesn't mean that it's finished yet. We get this answer, it doesn't mean we're wrong, but it's not complete yet. We need to put this r equal to 15 cm. So we put it in r. dA over dt equal to 18 over 15, and it's become the final answer is dA over dt equal to 1.2 cm square over minute. This is the final answer for this question.
So from question A, If the head of the water is twice the radius, show that V equals to 2 over 3 pi r cubed. So we just assign H equals to 2r, 1 over 3 pi r square 2r, because as you say in question A, head of the water is twice the radius, 2 over 3 pi r cubed. Okay, so then we proceed with question B. How fast is the radius of the surface of the water changing? Okay, so dv over dt equals to 15. So we need to find dr over dt. So we can use chain rule formula, which is dr over dt equals to dr times dv over dt. So dr over dv equals to 1 over 4 pi r times 15. So we will get 15 over 4 pi. So 15 over equals to 2. So 15 over 4 pi 2 over 8 pi.
Seriously, pay attention. This is important.
So now I want to read the question. The surface area of an ice cube is melting at a constant rate of 9 mm square per second. At time t seconds, the surface area of the cube is S mm square and volume is V mm cube. Question is, find a differential equation relating the rate of change of volume in terms of the cube's volume. I already draw the cube diagram, and as we know, the diagram have the same side, so I name the side as x. So the volume would be V equal to x cubed, and the differential equation would be dv over dx equal to 3x squared, and the surface area is 6x squared, and the differential equation would be ds over dx equal to 12x, because the cube have 6 surface area and x multiplied x, we got x squared, and we have 6 surface area would be 6x squared. Using the chain rule, we got two equations. dv over dt equal to dv over dx multiplied with dx over and the second question would be ds over dt equal to ds over dx multiplied with dx over dt. So here the two questions, this is the first one and this is the second one. So we rewrite the what we got so that it will become more clear. S over dt is 9 mm squared per second. Is negative
Because when the ice cube was melting, the volume will decrease and the value will be negative.
what we got is ds over dx equal to 12 dv over dx equal to 3x squared. So the second equation is ds over dt equal to ds over dx multiplied with dx over dt. So ds over dt equal to negative 9, ds over dx equal to 12x, and multiplied with dx over dt.
The negative 3 over 4x.
And first equation would be dv over dt equal to dv over dx multiplied with dx over dt. dv over dx equal to 3x squared, dx over dt equal to negative 3 over 4x.
The final answer will be negative 9 over 4x.
Calculate the rate of change of volume when the volume is 0.125 centimeter.
So, as we mentioned, we're using millimeter. We're not using centimeter. So first thing first, what we need to do is we need to
Change 0.125 centimeters into millimeter. So what we need to do is we just multiply the with 1000, and then we got 125 millimeter cube in volume.
So what we got before,
dv over dt equal to negative 9 over 4x.
so as we know, v equal to x cube. This is what we're doing, 3 root v. So we want to change x into this value. So now we got a new
Number dv over dt equal to negative 9 over 4 3 root v.
Okay, so now we already have the value of v, which is 125 millimeter cube. So
We just need to calculate the answer. Negative 9 over 4 3 root 125 4 multiplied with 5
negative 45 over 4 millimeter cube per second, or negative 11.25 millimeter cube per second. So we are done.